Hello everyone, in this video we're going to be starting with our study of one-dimensional motion. One-dimensional motion, 1D motion. Okay, and it may seem a bit basic, especially if you've taken physics already, but it is good to know the foundational concepts. Okay, with now applying our mathematically rigorous definition of vectors. Okay? Now, what is motion? Motion is the change, motion I would say is the change in position of an object relative to a reference point. So it's the change in position relative to a reference point. So if your position does not, well, what is position? Well, position is basically your location relative to a reference point. And you can use that in one-dimensional motion using a number line type thing. So let's say a flat ground, okay? This is your flat ground. And let's say this is your reference point, okay? It's some building. We will call this coordinate 0, okay? And that 0 just lets us know it is our reference point. Now let's say you were here. Okay, your position will be a vector. Okay, your position vector is just a vector originating from your reference point to you. And we denote the position vector using R. Okay, so R is your position vector. And R will tell you how far you are. What is your location relative to this point? And this is why it is important to have a reference point. If we had another building here, so this is R1, okay, if we had another building here, then your position vector relative to building number 2 that I just drew here is completely different, facing in the opposite direction. So position is a vector. You need to know what direction your position vector is, whether you're right of your reference point or to the left, whether you're above or below. And when you're moving, your position vector changes, okay? So if we had our scenario, undo all of that. If we had a scenario, and this is your initial position. This is your initial position. And you decide to walk a little ways left of your building. Your new position will be this vector pointing to the left. This vector pointing to the left, our final. Okay, and clearly the position vector changed. Both the magnitude of the position vector, okay, both the magnitude, you're a little bit closer to the building now, as you can see from the drawing, both the magnitude of the position vector and the direction, now the position vector is facing towards the left, both the magnitude and the direction have changed, which means your position vector must have changed as well, okay? And you can define the change in position to be equal to the final position minus your initial position. And you could see your change in position, you could visualize as this. And if you were actually to do the vector subtraction geometrically, it would look like this. a large arrow pointing straight to the left because you moved leftward. You moved leftward. Okay? Now, it's important as well to define a coordinate system when you're talking about motion. Okay? Which direction is positive? What is positive position? Because when you're dealing with motion mathematically, you need to have a sense of what positive and negative is. So by convention, usually rightwards is positive. Okay, and since we're only dealing with one dimension, we're only dealing with, we'll say, the I direction, the first unit vector. Okay, which means your position vector, Ri, is equal to some number times I. Okay, and your final position vector is also equal to some number times I. And this xi is basically the only component of this vector. It is literally one dimension. Okay, so we can define the change in position if we use our new notation now to be equal to xf minus xi times I, which equals delta xi. Delta just means change. So your change in your x position, that's okay. So you can think of that xi, xf thing to be your x coordinate. Okay, you can think xi and xf to be your x coordinate. Your coordinate relative to your reference point, this building over here. Okay? And when you're moving, this x coordinate changes. Now, one more thing we have to talk about. One more thing we have to talk about is the concept of time. Because you cannot move just instantly. You cannot just be here and the next instance you're there. Okay, some time has to pass. Okay, so if you started at a particular instant, ti. Okay, ti is your particular instant at which you start. Okay, let's say it's 12 o'clock. Okay, and 60 seconds later, so 12:01 is your final time. Okay? That is your final time. And all motion happens through some time interval. Okay? And your time interval is delta t, the change in time. Your final time, the final instant at which you ended your motion, minus the initial. Okay, and one final thing I want to cover. Is the concept of a position versus time graph. You can model all motion in terms of a position versus time graph. Okay, so if you started here, okay, time t equals 0. You're starting your time a little bit over here. Okay, time t equals 0. This is your t-axis. It always increases. And this is your x-axis, your x-coordinate, your x-coordinate. Okay? Then you can model your motion as a function of time t. Okay? So over here at this particular time, TF, I was at this particular x coordinate. Okay, at this particular time, I was at this x coordinate. Okay, so if we consider our initial and final position, okay, so let's say this time instance is your initial time, okay? This is when you start counting. Okay, this is when you start counting. This horizontal distance, that will be your time interval. This vertical distance will be your change in x, in your x coordinate. So as you can see, it's very easy to analyze simple motion like this on a graph. It's very easy to analyze stuff like this on a graph. Okay, so let's actually do a practice problem, because some of this may seem a bit strange. Although it is very easy to understand it intuitively, let's still do an example. Let's say you are here. This is your reference point, some building, okay? Now, let's say you initially started here in your car. This is your car, okay? And what we're going to do is we're going to define, okay? What we're going to do is we're going to move our car. We're going to move our car to the right. We're going to move our car to the right. Okay, so our initial time, so if we had a stopwatch, our initial time was 2 seconds. So we actually started recording at 2 seconds, and we were 5 meters away from our bank, or building, or whatever you want this building to be. Your final is 4 seconds. You pass this point when your stopwatch hits 4 seconds. And your final position is 8 meters. Final x coordinates 8 meters. So what I want to do is find out each of the position vectors, the initial and the final, as well as the change in position, and the change in time. Now, what do we need to do first? First, we need to define what direction is positive, because it depends for every problem, the direction of I. Okay, the direction of I will always be the positive direction, and by convention, we'll define I to be to the right. You can also define I to be to the left, but that will result in the position vectors being negative. Okay, so it's always easier to define I such that all your vectors are mostly positive to avoid mistakes. So we're going to define I to be in the rightward direction. Now our initial position vector, we draw a red arrow here. This is our initial position vector. Okay. And our initial position vector is equal to our initial x coordinate on our line, our initial x position, I, in the I direction. So because we defined I to be to the right, and your position vector is in the same direction, then we will have a positive number. Okay, so we have 5 meters times I. So 5 meters times I. So it's 5 meters away. Now your final will just use a line. Your final position vector will be this, and your final position will be 8 meters away in the positive direction. So it'll be 8 meters times I in the I direction. Now, what is our change in position? Our change in position is equal to your final position vector minus your initial. So we get, as a result, 8 meters times I minus 5 meters times I, and our change in position will be 3 meters times I. So we moved a total of 3 meters in the I direction, or in the rightward direction. Okay? And our change in time is also not that hard to do as well. We started at 2 seconds. We start at 2 seconds and ended at 4. So it's 4 seconds minus 2 seconds. So we spent 2 seconds in our short journey. Okay, so it may seem like a lot, but it is really intuitive. Okay, the time interval is how long it takes to get from point A to point B. Okay, your change in position is like how did your position change as it went from point A to point B? Okay, it is very intuitive to understand once you do examples. And as you'll see, we'll study how fast, the rate at which you change your position in the next video, and when we study average velocity. Thanks for watching. See you next time.